Okay, today our target is to use algebraic reasoning to solve multi-step problems with one variable. So we're going to fill in the blanks. When solving equations, you should move the expressions on one side of the equation. Then use operations, usually inverse operations. We're going to say inverse operations. Inverse operations to isolate the variable. So step one, you need to make sure that you combine like terms. This is something that we've already practiced, done quite a bit, but we're going to review it just to make sure that we understand it's all important to do that. So as you can tell on this side, on the right side of the equation, that's where the variables are. So we have a 5a and a 2a. It is encouraged that you rewrite it and make sure that you put the variables together with the appropriate operation or sign in front of it. So I moved those using the commutative property and then bringing the minus 23 and the equals 5. Then you're going to combine your like terms. Since I have two A's, two terms that have an A in it, that makes 7A minus 23 equals 5. I'm then going to use my inverse operation and add 23 to both sides. You get 28 equals 7A, not 8, 7A. You can, sometimes the book will say multiply by the reciprocal. I just say I'm using the inverse operation of dividing because multiplying by the reciprocal is dividing. So 28 divided by 7 is 4. 7 divided by 7 is 1a. So our solution is a equals 4 to this equation. We are going to do, the next one, we'll do b, and then I'm going to let you guys have some time to practice the other ones by yourselves and use this video to check to make sure if you're right. So I'm going to do the same thing. I'm going to combine my like terms, making sure that the operation in front of them follows. So 11b minus 6b. Then you have minus 4 and minus 4 equals 22. Now I combine my like terms. I have 11 b's. I subtract 6 b's, and I have 5 b's left. Minus 4 and minus 4, that is basically adding two negative 4's. So I have negative 8 equals 22. Now I'm going to use my inverse operation of subtraction and do adding. And you get 5b equals 30. The inverse operation, opposite operation, is dividing both sides by 5 to isolate that variable b. B equals 6. Okay, I want you guys to go ahead and pause and then attempt this one on your own. Make sure you're on the right track. I am going to work it at the same time, making it a little smaller. Negative 2c plus 5c plus 5 equals 14. Combining these terms will be 3c plus 5 equals 14. Now that I have it all combined, I'm going to use my opposite operation and subtract 5. So I have 3c on this side equals 9. Opposite operation is dividing by 3. So c equals 3. Did you get it right? If you got it right, fabulous. Go ahead and push pause, move to the next problem, and see if you can get that one. I'm going to do it at the same time. Going to rearrange it. 7d minus 5d plus 14 equals negative 8. Going to combine my terms, 7d minus 5d, and I have 2d plus 14 equals negative 8. Inverse operation means opposite operation, inverse operation. Negative 8 minus 14 more is negative 22. Bringing down my 2D because these are gone. Divide by 2, that makes it 1. Divide by 2, that makes it 11. So our answer is D equals 11. Hopefully you're getting these okay. Push pause, move to the next one. Give that a try. Gonna rewrite this. Negative 23 equals negative 2m plus m minus 10. When I combine these, I have minus 2 plus 1. So that is a total of 1m. I don't need to write the 1 because, well, it's negative. Maybe I should. Negative 1m minus 10 equals negative 23. All right, now the opposite operation, or the inverse operation, is adding 10 to isolate that variable of negative m. So these disappear. You're left with negative 1m equals negative 13. Now you'll notice that we are left with a negative 1 in front of m, and that means I have negative 1 times m. So I have to divide both sides by negative 1. And that will leave this as just positive 1. M equals positive 13. There is the answer to that one. Okay, now that we have completed all those, our next will be using a multi-step equation to model these situations. And what it says is Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. The bumper stickers cost $1 each. I'm going to make this a different color so you see it. Marcia's niece wants 1 shirt and 4 bumper stickers. And her nephew wants 2 shirts and no bumper stickers. If Martha's total is $67, what is the cost of 1 shirt? So first we're going to say let S equal cost of shirt. We have to do that so that we know what we're representing, and it helps us to figure out how to create the situation. Because if I start looking at this, I see there's 1 shirt, we do not know how much it costs, and here's 2 shirts, we don't know how much it costs. The information that we have is that the total is going to equal $67. So let's just break it into the niece. The niece wants a shirt. We're going to represent shirt with S. And she wants 4 bumper stickers. And we know those cost $4 each. So I can write 4 times 1. Whoops, not 4 times 4. 4 times 1. But then the nephew wants 2 shirts. So 2S. And no bumper stickers. So we've got to clear our parentheses. 67 equals S plus 4 plus 2S. And now I'm going to rearrange so that my S's, my variables, are together. S plus 2S plus 4. I know that looks like a 5, but it's an S. Now I'm going to move this over here. 67 equals 3S plus 4. Using that inverse operation, I'm going to subtract 4 from both sides. Doop, doop, doop. I'm left with 63 equals 3 times S. Using the inverse operation, I'm dividing both sides by 3. S then equals $21. So our answer is the cost of 1 shirt is $21. Make sure I can see your answer some way, shape, or form. Okay, so we're taking a little break from that, and we're going to go back to doing the distributive property and solving using the distributive property. So this isn't that different than our example 1 at the top, other than we have to do our order of operations. We have parentheses. We have to get rid of them. And in order to get rid of them, I have to multiply. So this becomes negative 8 times 2a minus negative 8 times 1. Now, I do want you to notice a couple of things. Please notice that there's a minus there, and that minus matches this one. But since this negative also has to be distributed to both numbers, I've also included it within the distributive property itself. When I distribute that -8, I have to multiply it by everything. So I'm going to go back and go ahead and solve. So -8 times 2a is -16a, minus -8 times 1 is -8, equals 3. Now I can hear it now. Hey. Do we need both of those negatives? And the answer to that is yes, because we have talked a great deal about the fact that we need to remember these rules, that if we are subtracting a number, we are actually adding the opposite, or opposite. There's different ways people are calling it. Keep opposite, adding the opposite, changing to the opposite. So in this case, since I have a minus and then a negative, I have to change both of those. So this becomes -16a plus 8 equals 3. So our inverse operations, I'm going to subtract 8 from both sides. I get -5 equals -16a. This is gross. I'm hoping I didn't mess up somewhere. Oh, I did. I forgot to bring down 36. That would be an issue. This is why we think if it didn't come out even, that's when I start going, where did I mess up? So this is 36 minus 8. 36 minus 8. I should be able to do that in my head, but I can't because I messed up, and that throws me off. So 28. Still doesn't come out pretty. But I think at this point, I'm going to have to accept it. So this means -16 times a. So I'm going to divide both sides by -16. A equals 28 over -16. I can simplify that with a 4. I get 7 over 4 negative. I believe that's the answer. If I have missed an error other than the one I already caught, please let me know. But I can't see it after looking very carefully. So let's do B. Still going to start with the distributive property. So 18 doesn't change, bring it down. But I change this to 3 times 2b minus 3 times 6. Now notice I brought down my minus here, see? And since that 3 up there doesn't have a negative, it's just regular 3. Positive 3. Now I clear the rest of the parentheses. 3 times 2 is 6b. I'm going to change that to a capital letter so that I can tell the difference between a 6 and a b. Minus 18. We're going to use our inverse operation. What we do to one side of the equal, we do to the other. I got 36 equals 6b. Divide both sides by 6. Inverse operation. B equals 6. Okay, I'm going to leave those for you guys to do. I'll try to go over some answers during class. It would be nice if I could do them and then give you the answers, but I do not know how to hit pause on this. So with that said, I don't want to do anything in my head and screw things up, but I want you guys to try them. I will write down the answers and make sure that you get them so that you can check your answers after. Let's see. Are these the same thing? These are not fun. So we are going to do this in a different video in case I need to break it into 2 days. So right now we're focusing on this. We will focus in the ones that will take a little bit more time, probably, well, definitely in a second video.